say we have something like this. X is equal to like 1 plus 2t. Y is, oh, I'm going to zoom in a little bit. Y is equal to like -1 plus 3t, and z is equal to something, right? T. And this is the equation of space line, right? Then we can make a vector function out of it too. R sub t is equal to usually whatever you have in x, which is a function of t, times I vector plus y, this y right here, times, which is a function of t, times j vector plus c, which is a function of t, and k vector. And these are equivalent expressions. Okay. Now, but instead of making it nice and simple and straight, linear, what happens if I introduce other functions like squaring t and things like that? So I'm gonna make sure this, you guys know, these are all function of t's. And then instead of putting this thing in, if I put cosine t here and sine t here, and then keep this thing as t, do you feel this? What does this thing look like? Or I can write it, think about it. Cosine t, I vector plus sine t, j vector plus t, k vector. Now, instead of a space line, we have a space curve. Can you imagine what that thing looks like? If you look at it from the top, xy plane, looking down xy plane, do you see between these two, do you see circular motion with a radius 1? Can you feel that much? But now the z position grows, the height changes. Do you see the stairway to heaven? Okay, there's a famous song about it. Okay, why don't I show you here? So 3D vector xyz is equal to, so we put cosine, not there. This thing is cosine t, sine t, and t here, right? Right there, you're saying that didn't work. Hold on. I need to change the t from 0 to 10, let's say. You see it? Stairway to heaven. Spiral that's going upward. You know what I'm saying? Do you feel it? So basically there's a cylinder, and then you're kind of like having a stairway, cylindrical stairway thing as you go up. Do you see that motion? Okay, now we'll come back here. Then I'm going to draw another picture. Say if we have some kind of cylinder that looking, oh, that's tilted. Why does it come out tilted? Hold on, let me try that again. And I'm going to intersect that thingy by a plane. So let's try to draw a parallelogram like this. Okay, so if the cylinder and then, you know what I'm saying? I want the equation of this space curve. That thingy. Okay, here are the equations of cylinders, and well, this is of course x squared plus y squared, let's say 4, radius of 2. Let's say this thing is x plus c is equal to 1. How do we find the intersection of these two? Oh, this may come in handy on that chapter test, eh? Intersection of the two surfaces, eh? Okay. How do we do such a thing? Ideas. Whenever you are finding intersection of anything, it's always systems of equation. You get it? However, this thing is squared and like, there's no z here. You see what kind of complex thingy that we are looking at? So instead of doing it that way, because we are going to have a parametric equation anyway, you know what I'm saying? So we'll start with x and y first. See, we have to have a circular motion. So why don't we just start with 2 cosine t and 2 sine t? So at least we have circular motion. If you're looking down from the top like before, now our radius is 2. Do you feel that? Now we are supposed to give an elevation, z value. Somebody give me a brilliant idea on how to figure out this z.
1 minus 2 cosine t.
Of course, right? Like, why is that? How did he figure it out? Do you all see it? Because from here, z is equal to 1 minus x, isn't it? And x, of course, is 2 cosine t, so we plug it in. Will that work? Well, there's only one way to find out, right? So let's go back here. Okay, I'm going to graph cylinder first. So here is x squared plus y squared equal to 4a. So we have that cylinder, of course, x. And then we are going to put the plane, which is x plus z is equal to 1a. Well, that doesn't show too well. Is it better? Let me zoom out a little bit. Do you see it? Cylinder being cut by a plane. So whatever that parametric vector function equation that we found has to wrap around right here at the intersection. Shall we do it? Yeah. So we go back here. We give the radius of 2. At least if I do it this way, it wraps around the cylinder. Do you see it? Okay. But this one now is 1 minus 2 cosine t. Ready? You see it? This ring around the cylinder at the intersection. Wow, dang, huh? Okay, I'm gonna take away the cylinder and the plane so you can see it better. And why don't I delete these things? And you will see there, space ring, space ellipse. How about that, huh? You feel it? Now, well, then I have a question. My question is this. What happens here if I put number 2 in front of this t? Predict. Let's see if you can feel these vector functions. Okay, fine. Ready? Whoa. Can you see why? I'm going to increase it to 4. Do you feel it? Or do I need to increase it to 8? Basically, it's a graph of this thingy wrapped around in a cylinder. isn't it? Feel it? Okay, that's this chapter. Vector functions, and we'll have to take a derivative, second derivative, and all of that. Derivative, of course, is a velocity, and second derivative will be acceleration. Then we can take it apart to linear acceleration and centrifugal accelerations. How about that, eh? Okay, do you have any questions? Okay.